Hello, Milwaukee. That was a hello just for James. Good morning, everybody. Do you ever have those mornings where everything that you try to do just sort of doesn't quite work out for some reason? You know, from the little things like I had a pack of label sheets and I was trying to get a sheet out of the pack and I couldn't quite grab it properly and I just couldn't get it out, so I was getting frustrated. And then I was trying to stick things on and I couldn't get them aligned. It's like every little thing you do just is not quite right. Yes, that's been me this morning. But first, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, a whole bunch of comments already. Yes, clickbaity. I suppose I am a bit clickbaity. I'm giving in. I never used to do like pre-arranged thumbnails for live streams. I used to just leave, you know, the default channel image up there, and I thought, since we're doing a since we're doing a specific topic and have been, I thought I would make some thumbnails for these ones. Toby said, all I can say about clumsy days is no to operate heavy machinery. Hey, how about soldering irons? We may be doing some of that today. So, hang on. I am so disorganized that I don't even have the chat properly pulled out. I've got to pull out the chat and I've got to switch it into live chat so that I can actually see the comments as they come in, not as YouTube rejiggers them. All right. Yeah, so rounding up the squirrel. Squirrel herding is hard. Yeah. Right. Now, where are we? What is this 3 out of a 20-part series, the Celtic Beast says. Maybe, but I have a good feeling about today. And so in the first 2 hours that we spent hacking around on the multimeter, we looked at some schematics, we pulled it apart. In the second 2 hours, we soldered on 2 wires. In the third 2 hours, I'm confident that we are going to get data out of it and get something pushed to MQTT today. So, Dodgy says, are we taking bets on how long it takes to get on topic today? Well, it can't be within the first hour. It's got to be longer than that. No, I will get onto it. But the other major topic of conversation on the Discord has, I don't even have Discord open. This is how disorganized I am today. Discord, go. The other major thing that has been going on over the last couple of weeks on Discord is discussion of the light switch controller project. Now hopefully my computer won't jitter while it's trying to launch Discord. It was struggling a little bit before. I was getting dropped frames even before I started live streaming. But hopefully we'll be okay. Yeah, so the other thing is the light switch controller project. There has been a lot of activity on that, and so a brief summary. One of the things, okay, this is going to seem like a really silly thing, like why would anybody care about this, but it's something that's been bugging me, which is how do I structure the storage of all of the different aspects of the light switch controller project on GitHub, and how do I manage those files? Because the thing is that the LSC is not a single thing. It's like an ecosystem of things that you can use to build a device to suit yourself. And so what I have been doing up until now is things like the breakouts, like the 24 port breakout, 16 port, and the 8 port breakout have all been in separate GitHub repos because they've got their own design files. And part of it is that if I put all of those things together, the question is, what is the version of the repo? And I suppose that doesn't really matter. But if, for example, I've got the 8-port version as released version 2.2, and then I do a 2.3 of the 24-port version, the state of the repo becomes a little bit strange because it contains multiple things that are released independently. That bugs me. I like to be able to point at a repo and say that commit in that repo is version 2.3, and you know what you're getting. But the problem is that when we've got software to go with these, if the same software relates to multiple things, do you put it out in a separate repo or do you merge it into one of them? If so, which one? And so up until now, I've had the software in its own separate repository, or actually multiple repositories. And also we're going to need software to run on AVR with hardwired Ethernet, software to run on ESP8266 or 32 with Wi-Fi, with hardwired Ethernet, software to run on a Raspberry Pi. So we've got multiple software options, each of which could be a whole tree in itself. And then there are other things like the mechanicals, the CAD design for the enclosure. There is the front panel. Anyway, the point of all of this is that the light switch controller project is not like one thing. It's like 7 different things that come together to form a whole. And they come together in a way that you can change it to suit yourself. So around and around in my head for ages, I've been going over this question of, where do I store the files? How do I set up the directory structure? If someone just wants access, for example, to the hardware design files of the 8-port breakout, should they have to download a repo that contains everything just to get to those files? Anyway, the upshot of it all is that over the last week, I've been starting the process of merging everything into a repo, which is the LSC repo, so light switch controller, which in itself is not a thing, it is like a collection of things or a meta thing. So if you go to, I'm going to pull this up on the screen in just a moment, and I'm going to show you the real thing in just a moment because I have got it right there. And desktop. Okay, so what we've got here is on GitHub/superhouse/LSC. This is where I've started merging things in. And so I've kind of combined the README. In fact, we're going to be looking at a fair bit of stuff online today. So I should zoom this in to make it very live stream friendly so that you can read it all. All right, so it's the Home Automation Light Switch Controller, the LSC repo. And what I've done is combined the descriptions of the different things, and there are renders of different versions. And right now, this URL goes nowhere. There should actually be something for that. But then in here, what we've got is a directory for firmware. And right now, there is only one folder inside that, which is LSC Arduino firmware. And Sumner Boy has been doing some changes to this already, which is really cool. There are, in fact, I could merge this. 13. We were just having some discussions about this. I might come back to that. Okay. And so first talking about the overall structure. So the firmware is in there. If you go into hardware, you can see pairs of files. So there is the 16-port board and schematic, 24-port board and schematic, etc., and the changes that are happening on them. Now, I haven't pushed in the last few days, but I've been continuing this conversion. So what I'm doing is replacing all of the discrete resistors with resistor arrays. And if we come back to here and look at the screenshot, and you'll see in the real thing in a moment, see all these resistors, rows and rows of them. And on this one, there are many of them. I think there are 90, it's somewhere in the order of 100 discrete resistors on the 24-port board. And what I need to do is add pull-ups, because I've been relying on the pull-ups inside the MCP chips, and I want to put external hardware pull-ups in here, which means doubling the number of resistors. Essentially, it takes it to about 200 resistors on this board. And space starts to become a problem. So I've been converting all of those to resistor arrays. I just haven't pushed that into the repo yet. So yeah, so there's a commit here which is like a partial conversion, but I've done way more since then. So the idea is that I want to have a single place as a jumping off point that can have information about all the different things that go into the light switch controller. And of course there's going to be the front panel. I haven't done any merging on that yet. In fact, I still haven't even verified that the hardware works on that. So getting back to this firmware, yes, we are going to look at multimeters. I promise, we will look at it. But this is kind of cool. So the firmware that I've got in here at the moment is for an 18 mega, and I've had my test device running on an Ether Mega. It would also run on an Ether 10, and I think some of the boys is running on an Ether 10. And so what you can see right here is the version that that I put up, and it's got some really cool little improvements in here compared to what I had previously. Like the way these bit masks work. This is optimizing reading the inputs, and a lot of this came from example code that was posted in the Discord, and I can't remember who did it, but thank you to whoever was posting the code snippets. I know Dodgy has been working on this a lot, and I think it was Lusu was posting code snippets and suggestions for bit mask stuff. So anyway, this is now using bit masks to, so what it does is instead of, on the 24 port light switch controller, you can have up to 96 inputs because it's 4 inputs per port and it's 24 ports. And my code previously was doing an input read on every one of those individually. So what this code does now is it reads an entire port. From the socket point of view, it's actually 2 ports, 2 physical sockets, but it's 1 port in terms of, no, it's actually 4 because it's reading 2 bytes. It's reading 16 inputs at once. It's got read GPIO AB, and it reads both port A and port B on the MCP. So it's reading 16 inputs in one chunk, and then it just spins in software. So this is a fairly dramatic speed up in terms of how it works, because instead of doing like an I2C communication with the chip and saying, tell me the state of input 1, and then coming back and comparing it, and then doing an I2C comms thing again and saying, give me the state of input 2, coming back and comparing it, it just says one I2C transaction. It says, give me the state of the first 16 bits, or first 16 pins, and then it comes back and processes them internally. So it dramatically decreases the I2C traffic and pulls most of the data in large chunks. So that's very nice. Anyway, the point of all of this is that Sumner Boy has looked at this and said, well, he probably didn't say this, hopefully he didn't. He said, that's rubbish, I can do better, and has put in a pull request and did some very, very nice changes. So we had a bit of a discussion about this on, like a discussion privately through Discord DMs, because there are a couple of changes in that Sumner Boy made that I don't necessarily think are bad, but are not the way I would prefer to do it. So, where are we? If we look at the changes, there were a couple of, here we go, view changes. Oh no, this is just the variations. Yeah, okay, let's go back to let's just go back and look at this commit. So he's cleaned up, I don't know if you prefer to be called Sumner Boy or Ben, I think it's, yeah. So Sumner Boy fixed some of my documentation, added a thing because this is his variation of it, set some stuff. This is all just cleanup stuff, improving what was already there. things like the names of these variables. I had G command topic, so that's a global variable, and the variable is a command topic, and he's renamed it to G MQTT command topic, so just making it more sensible. Fixed this. Oh yeah, I had button status with 8 because you can actually run up to 8 of the MCP 23017s, but he's reduced it to 6 because that's what's on the prototype. Added watchdog support, just some renaming here for niceness. Now the things that we'll actually get to, okay, there are a few interesting changes. So one is this change here, which is putting, I don't want to start a religious war on this one. I had the opening curly bracket on a new line, and Ben has put it back onto the trailing end of the previous line, which is the more common coding style. And this actually looks a little bit better to me. I kind of prefer this, and it's the way that I've worked for most of my life. The reason I switched to doing it this way is that this is the way it's defined in the bar group embedded C programming standards. And for the last maybe 18 months, I've been trying to follow the guidelines in the bar group standards. And there is actually a reasonably good rationale for why it should be on a separate line. I don't like the fact that it takes up more vertical, it expands your code, it makes it take up more space. And it looks a little bit strange if you're not used to it, but once you've used it for a while, I've actually started to prefer this. Some OLED cleanup stuff. MAC address. Now there are a couple of nice changes that Ben has made. If we get to, here we go. So what you can see here, in fact, if we compare this to, where's the bit that was deleted? Command? Yeah, okay. This is my old code that Ben has replaced. Just one example. The command topic is cmnd/ and then it inserts the last 3 bytes of the MAC address / command. And so I was just doing that using an sprintf with these bits out of the MAC address. And what Ben has done here is nicer. What he's done is we've got a device ID which is defined previously. Instead of using the 3 bytes out of the MAC address, it's already been generated back up here. And he's added this base topic. So there's this variable MQTT base topic, which is pre-pended to the rest of it. And that allows you to define something like, you could define your base topic as lights, or whatever you want to have in there. Now there is one little change which I asked Ben to make, which is to not include the leading slash if MQTT base topic is empty. Because with the current thing, with this version, if you don't set a base topic, you just leave that as null, your topic will end up as being /cmnd, and I wanted it to just start cmnd for consistency with Tasmoda, so that the topics come up looking just like Tasmoda topics. Now, one thing about MQTT, I didn't realize this for a long time, the slash means nothing. It's just like another character. In terms of the way the broker, like, we look at an MQTT topic and we think of it like a path, but it's not. An MQTT topic is just a token. All of the whole thing in its entirety is what the topic is. And the slash has no special meaning whatsoever. It might as well be, like, as far as the broker is concerned, the slash could be an A or a lowercase m or whatever. It's just another thing. It doesn't divide on the slash. It's not a delimiter. So if you have /cmnd blah compared to cmnd blah, they're different topics because the slash is just an extra character that is stuck in there. We're used to seeing the slash as being like the root of the file system and then you know, a breakdown. But in MQTT terms, it means absolutely nothing. So yeah, so my preference is to start the topic without that slash in there if base topic is null. And so Ben said that he was making that change, which is cool. Apart from that, I like the idea of having this base topic in there so you can configure it. What other changes did Ben make? Oh, he improved this significantly. So in the loop where it does the check, you can see that he's distinguishing between button press and button release events, and then they get called out to other places. I was just processing it directly in here. I had MQTT publish calls in here. He's pulled it out, which is much neater. Thank you for doing that. And what else? Other changes, button handlers. Oh yeah, here you can see the button released thing. And at the moment, button released is not doing anything other than updating the state. But the button press can push to MQTT. And initialize watchdog is in here, so I didn't have any of the watchdog timer in there. So very cool. Oh, and one thing that is really neat. So what Ben's done is he's deleted config.h, well, renamed config.h to config.h.example, and then modified the .gitignore file so that config.h will never be committed. And what that means is that you can check out the repo, copy config.h.example to config.h, and you can edit it and put your own username and password and everything in there, because in here it might have things like your MQTT username and password. And I've been caught by this before. Having a local copy of a config file, and then you just do like a git add dot, and it adds everything, git commit, and you've just committed your config file with your local username and password in it, which is bad. So, in fact, I actually did that only a few days ago. Luckily, I hadn't yet pushed to GitHub, so what I did was a git reset, and I basically just rolled back that last commit and and erased it from reality. So it never got out, but I've come very close a couple of times to pushing to GitHub with committed usernames and passwords. So yeah, that's a really nice little thing from a development environment point of view. So basically, Ben has done some really nice stuff in here, and I like it, which is cool. So this is all part of summarizing the fact that in the light switch controller project, there has been a lot of action recently, and yeah, that's a good thing. So I'm just going to push yep. Oh, okay, so as I've been ranting, I've been ignoring the chat. Peter Lawler says, sub-projects in Git are awful, Git is awful. I love Git. Sub-projects not so much. And things like external dependencies, they can break my mind. But Git itself, I love it. Don't you say bad things about Git, Peter. All right. Now, where are we? Austin had a very nice suggestion. Austin's Creations. I wonder if you could run the I2C scanner at startup and have it auto-identify the number of MCP and buttons connected. Yes. Yes. We need to put that in the, hang on, where I can open an issue for that. Issues. Okay. Let's make a new issue. Come on. Auto discover MCP 23017. And auto configure for number of input ports. How is that? So now we have an issue. And James said it does use the slashes, and that's how we can use wildcards. I don't think that's correct. I'm pretty sure you can use wildcards anywhere. They don't have to be in between slashes. In the code for, say, the Mosquito MQTT message broker, it doesn't look for slashes. Like they're not special cased. They are simply part of the character set. So they have no meaning whatsoever, any more than any other character, as far as I know. But maybe someone who knows more about the internals can clarify that. But I haven't actually looked at the source code for Mosquito myself. I've been told by someone who is a Mosquito, like who has actual commit privileges for it, that slashes mean nothing. So I think you can even put slashes inside the wildcards because it's just another character. Like if you have a wildcard that is substituted into a topic, the value of the wildcard could be a slash if you wanted it to, or it could be multiple slashes or whatever. So Dodgy said, is there a debounce on button press and button release? Not yet. Okay, so other things are, we want to do things like multi-press detection, long press detection, and, oh hang on, I had debounce on it, but it was really, really crude. I was just having like a couple 100 millisecond delay between, before it would process anything else, which really sucks. It's a dodgy way of doing it. Yes. Unexpected, Sion says, I have a love-hate, more-hate relationship with Git. Yeah, I think maybe one of the reasons... Oh, Aaron said, label this as new feature. Yeah, it's not a bug, it's a new feature. So... I think... Yeah, Sion, you've been developing software pretty much your whole life as well, so I'm sure you've got experience of other revision control systems. But yeah, I've used a few over the years. What have I used? I've used RCS, although not a lot, like only, a little bit many, many years ago, like 20-something years ago. Bazaar I used, BZR for a while. Subversion I've used for a while. Subversion I used for a long time, long time, many years. And so yeah, I switched to Git, and basically because of its branching and merging, it is so much better than Subversion at branching and merging. And when you're working in a team, that is really critical. So, oh, there's already a comment from Austin. Thanks, Austin. Labels. Let's see, what labels do we have? Invalid, we don't have a label here for new feature yet. Oh, anyway, doesn't matter. I don't particularly care about the labels. So, oh yeah, Michael Wise said, RCS is good for when you're working with local files rather than pushing things between hosts. Yeah, but I use Git for that as well anyway. Like, I keep everything in Git. It's even stuff I'm never going to push or publish or whatever. So, before we get on to the multimeter, which I do want to do, ta-da! Oh, hang on. Let's do that again. Ta-da! So this is the current prototype for the light switch controller. You can see it. So this is in the laser cut steel enclosure. The enclosure was laser cut, but none of the front ports. I had to cut all of those by hand. So it was a real pain. And I've got, I can show you. How about I show you on this other camera? You will get a better view. So, where can I get it? And also at the moment, these are just stickers. So this is laser cut steel, and then it was folded on a CNC folding machine. And then I primed it and painted it. So this is just spray painted white. And then these are stickers. But ultimately, if I produce more of these, what I want to do is find someone with a UV cured inkjet printer. So this will all be painted and then run this through the UV cured printer so that the labels and things are all are really strong and it's not just a sticker on the front here. So the idea is that it looks kind of like halfway between a cross between an Ethernet switch and like a cobalt rack sort of thing with the control panel over here. At the moment, this control panel doesn't work. Like whatever is going on with this, I haven't even looked into what's going on with that yet. The previous version did work. I had the display working, and then I switched to a larger OLED because originally I had a 128 by 32 OLED in here, which is like a little strip, and I've gone to one that's twice as high. I think it went from 0.96 to a 1.3 inch OLED. And so yeah, I've got numbered ports now. It all looks really cool. So you plug in LAN. This particular one, so I've got Ethernet pass through here. Oh, and you can see that on the PCB, where does this go? There. Oh, it's too dark. You can see there's a footprint just there for a DC power jack, which is meant to protrude through the front panel. And I didn't cut that or populate it because on this particular one, what I'm doing is running pass-through Ethernet here, which comes down to this Ether 10. The Ether 10 has power over Ethernet support, and then I've got this little proto shield, which has got I2C breakout and a watchdog on it. I2C comes down here to the back of the control panel. It passes through the control panel, comes out on this other ribbon cable, comes to the RJ45 breakout, and to all of the front panel ports. So let's plug it in. I don't know why, just cause. I'm knocking stuff off all over the place. All right, so I'm going to inject some power onto that Ethernet cable. So we've got LAN here, plug it in. You can see power comes on. The Ether Mega has powered up. It'll have an IP address now, and it will be connected to MQTT. So that now is live, and if I plug a switch into it and press buttons, it'll publish to MQTT. Because what's running on this right now is the firmware that is in that GitHub repo that we were just looking at. And that is running just fine. Now, oh, which reminds me, one of the other things that I'm wondering whether this is even worth mentioning, but I think it is because there are going to be people working on other firmwares for other boards behind this, which is the numbering of the ports. So in my original code, when the inputs come into the MCPs, the bits are numbered from 0 to 7, of course, because that's the way binary works. You know, bit 0 is the first position. So the value you get back if the first input is asserted is essentially its bit 0 is asserted. And so on my original thing, the ports would have been numbered 0, 1, 2, 3. And then I added an offset so that all of the ports are numbered from 1. And in the code, that's kind of a little bit strange. It seems counterintuitive because it's bit 0 that represents the first pin in port 1. So it looks like there's an off by 1 error in the code that's been deliberately added because I've done a +1 on all the values. But I did that because I wanted the labels on the front panel to be just like an Ethernet switch, and I wanted it to be 1, 2, 3, 4, not 0, 1, 2, 3. So that, if you look in the code and you see there's this little, you know, port ID +1, that is the reason. It's to offset everything into human readable things, because in the physical world we count things from 1, not from 0. Sion says no display on screen. No, that's because it is broken. Well, I haven't got the code in that running the screen properly yet. Okay. Yeah, Sion said Git is great until something breaks and you destroy your brain trying to fix it, and so just kill it and then refork. Yes. Yeah, git reset -- hard and MV the directory to something else and then check it out again. I am familiar with these tactics. Yes. Okay. Oh, this could be interesting. So Aaron said, going back to last week and you deciding whether to put power caps per Ethernet blocks or not, thus truly mirroring the circuit, future-proofing for future light switch hats for sensors. Yeah, yes, you're right. So I was thinking about that a little bit more, and I realized that what I said in the live stream last week was wrong. Well, it wasn't wrong, but it wasn't the whole story. Because what I was thinking about was light switches. Where is one? I had one right here. Another one of these situations where I'm going to hold something up to the camera and wave it around for no particular reason, just because it's a prop. So the standard light switches that I use like this, with the breakout, this breakout has nothing on it except some little surface mount resistors, which are current limiting for the LEDs in the buttons and pull-ups, I think. Can't remember if it's even got pull-ups on it. So this, if you're supplying power from the light switch controller to a whole bunch of light switches like this, they are not drawing power in any spiky sort of way. Their current consumption is going to be absolutely rock solid because all it's doing is running some LEDs. They're just drawing a constant amount of current, a few milliamps each, and that's it. So power decoupling pretty much doesn't matter. So that's why going through my head, I was thinking I could just take off so you can see a couple of caps there, these electrolytics. I could take those off and just not care about power supply decoupling on the breakout. Just feed the V in 12 volts to the devices and that's it. But then I realized that for things like the smart switch, which has got an ESP8266 in it, do I have one here? I do, but I'm not going to waste time that we could be messing with multimeters going to look at that. So they will have much more bursty power requirements. So having some decoupling on the power rail here, I think, will be a good thing. So I don't know what size yet. Now that I'm restructuring everything with what I had been wanting to do was put like one cap here, one here, and one here. So there is one directly behind each of these blocks. But on the version that I'm converting to resistor arrays, there actually isn't room for that because what I've got is, see, we've got 2 columns of resistors here. On the converted version, I've got 4 columns of resistor arrays, and that space in the middle is full. So there just isn't room there to put a big cap in there. Although I might be able to arrange it. A little bit of pushing and shoving. And also the other thing to keep in mind is that electrically, this PCB, I think it's the top. Yeah, the top is ground. The bottom is the V in, so that's the 12 volt pour. So these capacitors are electrically in parallel across planes with 2 big planes joining them. So in terms of physical proximity on the board, it doesn't make a huge amount of difference where they are. I just like them to be symmetrical. Oh, Aaron said ETH0 is always port 1. Yeah. Yep. Okay. Yes. Michael said, can I get one in plaid? Yep. All right. Peter Kirkhoff said, countdown is on. Will the multimeter push out MQTT? It will. I am sure of it. Of something. It'll push out something. Okay. Oh, Alistair, cool, nice to see you here. Alistair is a brainiac genius, so I better pay attention to what he's saying. I'd be concerned about inductive coupling into the switch lines. I had to disable local switches on a bunch of Kogan smart plugs as they would false trigger with an adjacent mains line switch. Yeah, okay. Interesting. Yeah. It's a lot of these things are situations where you can build something and it works on the bench and then you install it and it doesn't work. Or it works on the bench, you install it yourself and it does work, and then other people install it and it doesn't work, or it has intermittent problems. And that sort of thing can be really hard to track down. So a whole lot of the projects that I've done over the years have been a case of, it works for me. It's like developers saying, it compiles on my machine, and other people can't get it to work. So, yes, you're right. It is very possible that I'm going to get to it. I'm going to get to this thing. Okay, I'm going to start unplugging this while I'm talking. It is very possible that things that I build and seem to work fine for me will fail for other people or in other situations, or will fail intermittently. And so I need to keep that in mind and try to make things as robust as possible. Where can I put this? I'm just going to sit it over here for now. All right, so yes, multimeter time. Multimeter time. Let's see what we can do now. This is where we left it yesterday. There is one little change that I have done since last week. Not yesterday. Last week. All right. Last week, where we left it was with these two wires connected to the board, the internals of the multimeter. So we've got a connection of ground on the multimeter, and the yellow one is the data out. So SDO pin from the chip, from the multimeter control chip. And we pull those up onto the oscilloscope and we can see that we're getting data packets. Now what I've done in preparation is I have soldered pin headers. Let's get some zoomage. Zoomage. Okay. I've soldered pin headers onto these because I want to be able to stick these into, that one slipped. I want to be able to stick these into a breadboard. Now this is a Lowland 32 light that, what was I doing with this? I can't even remember. I think I might have been using this for the Zero Stick project. Anyway, it's an ESP32 based board. So what we're going to do today is see if we can get data out of this. So at the moment I'm just totally ignoring that optical interface. We just, we've got data coming straight out of this. So let's see what we can find. Ground, I've connected to ground on here, and also in preparation, what I also did, let's get that out of the way, is I have made a couple of sketches that we can mess around with. Let's see, hang on, let me get myself organized here. What have I got? Let's get some things up. Okay, so please excuse this interruption. I'm just opening things and I've taken it off the screen because I have this classic problem where when I open stuff in Arduino, I don't know if it's going to open client projects and reveal things. So now I think I am all good. All right, here we go. Desktop. Is it? Yep, you can see that. Cool. So what I've done is I took there is like a serial reflector example project in Arduino, and what it does is it opens a serial port and well, it opens two serial ports, and then data that comes in one port it sends out the other, and vice versa. So that's why it's called reflector. It takes data from one place and basically just bounces it through, and it can be at a different baud rate or whatever. Anyway, so the idea with this is that I want to use this to see if we can get data coming back from the multimeter. And so this is using hardware serial. What have I got my compilation set for at the moment? Mega. No, I don't want that. That's because I was messing around with light switch controller. Where are we? ESP32 Arduino. And Lolan, which one? Wemos Lolan 32, Lolan 32 Lite. I think that's the one we want. And I should plug it in and find its serial port. It should be 301. I've got the ports on my USB switch, my USB hub labeled. Now, what have we got? 920, 40, and which port? Where's the port? Come on, should be one of those. 14630, is that it? I'm just going to unplug it. Oh yes, it is, it's 630. Yep. And so, yeah, 14630, that's the one. Okay, so what we want to do is open the regular serial port to my computer, and we want to open another hardware serial port 1, pins 16 and 17. Is this right? Pin 16 and 17. So 16 would be RX, and so I'll plug, don't know if you can, oh, you can't even see that. Okay, so what I've just done is the data pin I've plugged into pin 16 on this board, and I'm going to turn on the multimeter so that we've got something happening there. I should probably connect it to a power supply or something. And then let's, where are we? Back to here, desktop. Okay. Now, the oddness here is that, as I mentioned, I think way back 2 weeks ago in the first live stream where we started messing around with this, it's not an 8-bit, the serial connection is not 8-bit, it's 7-bit. So it's 7-bit with odd parity and 1 stop bit. And we've got our RX pin connected to 16. We can't actually talk back to the multimeter. So 17 doesn't mean anything. And this little loop, all it's doing, and also this is just a single directional thing. Normally what you would do if you're doing a serial reflector would be something like this. You would do if serial available, and then serial, and then I would do UT61e write. So if there is data from one port, it writes it to the other, and if there's data from this port, it writes it to the other. But we're only going single directional, which means we want something like this. So let's see. Yeah, DMM has nice reflection of lights. Yeah, it's that's the box locator strip of LEDs across there. There is a command I can use to, oh, you can just see it. If you look up, hang on, I'll go to the, oh, what was that? Error compiling. Light. I think I might just, I have a feeling that I need to pick, no. Sorry, I'm thinking about the other thing. ESP32 Arduino, that's what we want. Wemos Lolan 32, I'll just try that. Okay. Yeah, there's something weird that has gone on with the Lolan 32 and the light, and it's yeah, well, that should be okay. And it's Originally Wemos released two boards. There was the Lowland 32 and the Lowland 32 Lite. And then they got cloned. Other people started making equivalent boards. And a whole lot of people started making boards that were like they were identical. They were basically a clone of the Lite. And they started selling them as Lowland 32 without the Lite in the name. And so it's actually really confusing. If you buy a Wemos Lowland 32, what you get, configuring flash size, what have I done here? I'm just going to unplug this from there, and I'm just going to try again. Yes, I know I'm not reading the error messages. I should be reading the error messages. So, yeah, what you get, maybe I've just got the wrong port selected. Hang on, unplug that. Let's see what ports we've got. Port. No, it is that port. Well, this is a stupid thing to be stuck on. Can't even... what am I doing wrong here? Zero reflector, yeah. And you're probably telling me, I've probably got people in the chat telling me what is wrong. I'm just going to try dropping the baud rate. That is often a problem. That'll often give you the programmer does not respond sort of error. Particularly I found if I'm going through this external USB hub, because the hub's kind of dodgy. Why is it that all USB hubs are dodgy? I keep thinking I want to make a USB hub. There have been some projects to make like hacker-friendly USB hubs, and because other people have been working on it, I haven't bothered. As I think I've said before, I did design a USB hub quite a few years ago. Oh, look at that, it's working. Yeah, I think it was just the baud rate. It couldn't handle that speed through the hub. Okay, now I'm going to connect it all back together again. So I'm going to plug back in ground and data, connect it to pin 16. Multimeter is still turned on. And what do we get in the serial monitor? Hang on. Oh, hang on. It opened on the wrong monitor. But check this out. This is the serial monitor coming back. So this is the serial reflector. And you can see that we're getting chunks of data in here. Now, as you might remember, we looked at data formats previously. And if I remember correctly, it was like a 14-byte packet or something. UT61e serial protocol. So, if you look at the refresh rate on that, I'm just going to hit enter a few times to make some, but no, it doesn't work. Hang on. I will close this and then open it again, which should force a reset. And that's about to a second. That sounds about right. When we were reading the datasheet last time, here we go. The sample rate coming out of the multimeter chip is 2 Hertz. So this looks like data to me. You can see by the links I've followed that I've been digging around, looking at things, reading stuff. All right, so we've looked at a couple of these pages already previously. Look at this. Here we go. So we've got data. I mean, the values aren't the same, but the basic structure looks the same. I think we actually have data. So here it says numbers in voltage mode. This might be a little bit hard for you to read. Let's get some zoomage happening here. So 107393 corresponds to 07.393 volts. Dot is after 1 plus 1 equals second digit in value. 1, 2, 2. Okay. 10. So the first digit is like the position of the decimal point, and then the rest of, how many is that? 5 digits, and then there are 5 digits of value. Yeah. In volt mode. In ohms range, it looks like it's different. Okay. But we have data, so now we can start to try to do something with it. Back to the chat. What's everybody saying? Oh, Joe said, didn't you disconnect the multimeter? Yeah, but then I plugged it back in again. Yes. Oh, Andy, hey. Good to see you here. Every appliance and device should be connected via MQTT. What I should be doing, Andy, is checking up the back channel. So for those of you who don't know, Andy is very, very helpful in paying attention and prodding me when I overlook things in the chat. Okay. Streams. All right. So I've opened the back channel just in case Andy wants to slap me upside the head. Okay. So Andy is the person to clarify. I was making this wild statement earlier that slashes mean nothing in MQTT topics, and as far as brokers are concerned, they don't see it any differently to any other character. So, Andy, can you confirm or deny? Does slash mean anything at all in MQTT topics, or is it the same as if it was like a letter, a number or a letter or something? So my understanding is that it is just another character. It is not a delimiter, any more than A is a delimiter. So back to this. All right, so we've got some data. This is cool. Now, we can start to push some stuff. We could even push this raw data if we wanted to offload responsibility for any of the processing of it and the parsing of it. So let's try, what are we going to do? Oh, okay, so anyway, this sketch that I've got right here is the serial reflector that I prepared before this, and there is, where are we, Finder. So this is a serial reflector. The other one, UT61e Wi-Fi. This is a skeleton of a project that I think I mentioned last week. I actually did this before last week because I thought that last week we would get to the point of pushing data. I was so wrong. So what this is I made a copy of the particulate matter sensor, so the air quality sensor project, and I didn't even change stuff in here. But basically I just ripped the guts out of it. I removed all of the stuff that communicates with the air quality sensor. I trimmed down the reporting section. It's got the init Wi-Fi section, it's got reconnect MQTT section. Ooh, I just realized I had better not click on that config, or I'd better move it off my screen before I do, because that will probably have all of my Wi-Fi details in it. So I made a couple of minor changes. So what we've got is basically the skeleton of a project that can connect to Wi-Fi and it can push stuff to MQTT. So this is me being lazy or smart like a fox, whichever way you look at it, and reusing things instead of writing from scratch. So we've got a project that will allow us to publish data, and as we have just seen, we can get data. Right now it doesn't mean a whole lot because it's just that, whatever that packet format is. But what I want to do is now start hacking around on this so that it will, so that we can push it. So let's, I'm going to drag this off my screen for a moment so you can't see it. I'm going to have a look in config because I've got to find out what I put in here. All right, I have got my Wi-Fi details, and it's got, so I have a couple of MQTT brokers running locally. I have my, like a real broker, the one that my house runs on, which is password protected. And I've got another one which is not password protected that I use for, you know, just pushing miscellaneous stuff through. And part of the reason for that is that when I'm filming videos that involve MQTT, I often need to be able to show the configuration, and that way I can do it all on video and I'm not revealing details of my real MQTT broker. So what have we got? You can't see it right now, obviously. I'm just taking a look in my config file. All right, I've got the broker set up. I've got no username and no password, which is good because that one doesn't have a username and password. Okay, we shouldn't need to open that tab again, so I'm going to close it and bring this back on screen. All right, now, what do we have? Well, I suppose the first thing to do is just find out if it compiles. It may or may not. If it doesn't, I will not be surprised. I think I actually did test compiling this previously after I just deleted a bunch of stuff. And okay, so where are we going to begin with this? What have we got? Let's change. It's still compiling. Come on. Come on. Come on, you can compile faster than this. Nearly there. Done compiling. Okay, and no error. All right. And now, just because this bugs me, air quality sensor, let's say UT61e multimeter Wi-Fi interface starting up. Open a connection to the particulate matter sensor. Yeah, so this is, I just commented this out before. So previously I had serial dot begin, and it was going to the PMS. And so what I did was I just substituted the, I may have even done a global find replace to replace PMS with UT61e. No, because if I'd done that, it would have changed it in there. Yeah, I thought I did that anyway. So hang on, I've got to get back out of here off screen again. So that definition of the UT61e RX pin, and so the RX pin was 16 and TX was 17, even though we're not using it, was what we learned from the serial reflector that we were just looking at. So hardware serial port 1 on an ESP32 is on pins 16 and 17. So what have we got? That is defined. Oh, this is wrong. So what I'm going to do is we want this to be 7-bit odd parity 1 stop bit. All of this can stay the same. Previously we had a whole bunch of different topics. I deleted a bunch of them, so now we only have a raw and a JSON topic. Oh yeah, so this brings up something, which is how this should be reported, because of course multimeters can go into different modes. You could put them into volts mode or ohms mode or, you know, whatever. So I don't think it makes sense to just have like a value topic, because you also need to know what mode it is. So this is something that that we can all decide together is, Cable Tie said, what is on the DMM screen? Good question. If I put this onto overhead, can you read it? No, you can't read the, okay, I'm going to connect the multimeter to some kind of a voltage source. What have I got? How about a bench power supply? Just so that we can get some number on the screen. At the moment, if I just touch these, it's giving sort of randomish numbers because I am electrically charged. So what have we got? Multimeter, I'll set it to, I set 0.05, 12 volts, go. All right, so now I've got 12 volts coming out of my lab supply. Oh, can I make that a bit more readable? There we go. So I've got this connected into my bench power supply, which is set to 12 volts output, and we're reading 11.983. So, and it looks fairly stable, 11.983. Let's go back to here, and would ya look at that. 11198, well, it's 4 now, 983. So that number is actually the reading that, yeah, that we expect to see. That's cool. I'm just gonna, while that's on the screen, I'm gonna go back to my supply and I'm gonna change it to 6 volts. VSET 6, go. It'll take a little while to fall. Now it's reading 6.0 volts and the multimeter says 5.995. Yes. Right. Okay. Yeah. Aaron said, the last time John played with Arduino IDE, didn't he take down the Aussie broadband? Yeah, there was like a statewide outage. I don't think that one can be blamed on me. Yes. Well, as Scott Miller said, how many viewers do you think will drive to your place and hack your Wi-Fi? Well, I've had people find me multiple times actually. As in people that, so far it has not been malicious, but multiple times I have had people either turn up at my house, having done things like a bit of investigation to like digging into my videos, looking at Street View, and figuring out what my address is. So yeah, it happens. Post your address also, please. Yeah. Actually, maybe I shouldn't draw attention to this. I got a phone call, I think, when was it? A week ago, a couple of weeks ago, because I recently showed one of my lab notebooks on a live stream, and it's got a label on the outside of the notebook, and the label has my name, email address and phone number on it, so that if someone finds the notebook, they can contact me to get it back to me. And it's got confidential and stuff written on the front. And so I got a phone call from someone saying that I revealed my details. Yes, on the live stream. It's that's what happens when. The thing is that this is where I work. This is where I spend way too much time, probably like 14 hours a day, most days of the week. And so I'm surrounded by stuff that is actually confidential, and filming is always a little bit of a juggle. I've got to make sure I don't point the camera in places that I shouldn't, or I get things and move them out of the way first. All right, so yes, Mako said squirrel. I know, I'm chasing a squirrel. Decimal bit, Aaron said the decimal bit isn't doing it on yours, John, at 5 volts. I'm assuming the first bit should be 2, not 1, and when it was 12, it was still 1. No. Yeah, so 1 is correct according to, where was that page that we were looking at before? What am I doing? This. So this, where it was talking about the position, so the first digit plus 1 is the location of the decimal point in the value portion. I think I've said that correctly. So if the first digit is 1, then what the actual position is 2 in the, so that is the value portion. So you would move it to be in a position 1 after, like the second thing. So that would be 7.893. And the thing is that the way multimeters work is that, oh, this is a squirrel that we could chase and that I'm not particularly qualified to chase, but I'll just mention it briefly. The way they work is not based on the number, it's based on significant digits. It's not based on number of digits after the decimal point, I think. So if, so basically when it goes from say 9.9999 volts, that is 5 characters or 5 digits. When it goes to 10 volts, like 10.001, it can't go to 10.0001. You lose one of the digits after the decimal point because the number of digits is the same. It's like a moving window. So when it's at 12 volts, you can see how we've got the leading 0 on here. When it goes from like 5 volts to 12 volts, so at the moment it's set on 6 volts. And if we took that first digit and make it 2, because it's that digit plus 1, and then we move it to after the second digit, so 1, 2, that would actually be reading 5.996 volts. And we have 5 significant digits, including the leading 0. I think that's kind of the way it works. Maybe I butchered that explanation, but it's something like that. So I think the number that it's showing us is actually correct in terms of where the decimal point should be. All right, so let's get back to this because what is the time? 11:16. Today, folks, we are going to push this to MQTT. I'm sure of it. What have we got? Okay. So first thing is, let's, okay. Sorry, getting my head back into this code. All right, we're opening a serial connection to the multimeter so that we can get data, setting up all of the topics, blah, blah, blah. That's right, that's what I was talking about before. What should the topics be? Right now, for today, I'm going to start by just taking this raw value, whatever it is, and I'm going to push it into raw. But we need to think about how we're going to report this. Are we going to have a volts topic and an ohms topic and an amps topic and all of those sorts of things, whatever the functions are whatever the modes are on the multimeter, and then publish to those values based on the mode of the multimeter? Because one of these digits, one of these characters that's coming back here is actually telling us what mode the multimeter is in. If we look at, I don't think it's on this page, but yeah, there are many, many pages with information about this protocol. Somewhere in here, I was reading, which one is it? Maybe this one? There is a breakdown of here we go, this one. Hang on, no, that's not, this can't be right. UT61, the first digit plus or minus? No, precision flags, that doesn't look right. I think this might be for a different Unity multimeter. But in any case, you can see here unit is one of the things that they do. UT61, yeah, I'm pretty sure this is different because the thing is that very confusingly, oh yeah, this is for the UT61D, which is a different multimeter. it's really confusing that UniT, so Unitrend, the company, release multimeters with the same number except for the final character, and they're totally different devices. They do have different features, different, they're just different. So yeah, you can say, oh, I've got a UT61 multimeter. That means nothing. It's like just saying you've got a Unitrend multimeter. It could be a UT61A, B, C, D, E, and I think there are even more characters now. So let's just have a look around here. Yeah, anyway, we'll get to this point. For now, let's just get this thing pushing to MQTT. So, oh yes, so I see there is some interesting discussion. Yeah, Peter, everyone knows the real password is asterisk, 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 asterisk. Swordfish. Terrible movie. I can't even remember what happens in it. I've blanked it out. Yeah, so there have been some interesting discussions about decimal places and things. But I am going to try to avoid getting into that right now and get this thing publishing to MQTT. Okay, so we've got a loop. What is it doing? We want to do what? We're connecting to MQTT. We're doing all of the stuff. Oh, that's right. This is what I put in last time. When I gutted it before when I was chopping all of this down, originally in here, this is where it was calling out to get the data from the air quality sensor. So what I did was chop it down and just generate a random number so that this will do something. Let's just upload this. All right, so I'm going to stick this sketch as it is onto that Lowland 32, and I'm going to get myself a console so that we can start seeing what happens on MQTT. I'll just move that somewhere that you can see it. And I don't know what the topic is yet, but mosquito sub. That's my my open MQTT broker. Oh, look. Okay, so here we've got, what are we doing? That. I want that topic. That one. Oh, come on. Did I actually get it into the buffer? No, I didn't. Ah, that's annoying. All right. No. Oh, I've got to do this again. I should have turned off auto scroll or something before I did that. -T. What have we got here? CMND. What's the device? BD9E 7C raw. Am I going to get anything? No. What have I done wrong here? BD9E 7C. Am I even publishing? I don't know. I can't remember. What is this doing? Client.publish. Message buffer. Hang on. Let's do I have a feeling that this might be, yeah, what is, oh, it's teller instead of command. Okay, of course it is. Yes, I know, everybody has been shouting at me. Okay, there we go. So we've got this random number being generated in here. and it is being published to MQTT. So we've got a bit of data coming in. So what we need to do, this is the crux of it. Right in here, we need to get data from the multimeter. So we can do that. Let's see. UT61. What I'm doing here is, hang on, I'm going to go open recent, serial reflector. This one, okay. This part of it, basically this. Okay, let's take this. That's going to form the start of what we're doing here. So we're taking the data. If it's available, then we're going to write it to the serial port. So this is just replicating the functionality of whatever was going on before. We got this delay in here. We'll have to get rid of that, of course. That's just because I'm reporting the random value. And let's see, message buffer. We want to set up a message buffer. Do I have a message buffer in here yet? Yes, I do. Okay, so what are we getting? I'm just going to push this onto the thing again. So this isn't really going to make any major change, except that it's kind of not going to work. Oh, UT61e, oh, of course, was not available. I didn't do the setup up here. Serial 1.begin. So we did a I want to hardware serial UT61e. This is like what? This is basically the same as in that. Let's see if that works. As in the reflector script that we were just looking at. Sorry, I had the object in that and then I didn't copy that part across. So we've got to create the hardware serial port object using hardware port 1 instead of 0, which is the default. Hey, it compiled. It's uploading. Now, I'm just kind of scrolling randomly. Where are we? Getting back to what we were... Where were we? Init Wi-Fi. Do we have multimeter connected? Yeah, this is all going to be quite screwed up at the moment because it's yeah, we're reading something from the other port and not doing anything useful with it. Well, I was trying to take I would have expected to be seeing, like, every 3 seconds we would see a thing coming in here because it should be in the serial buffer, but it's not. I think I'm probably just, I'm kind of just flailing around and not doing anything useful at this point. So, okay. Let's start by building up values in the buffer. All right, I'm going to get rid of this random... Oh, hang on. Oh, I know what's going on. I was looking at this and thinking that this is random numbers. It's not. Ooh, this is interesting. Okay, I had a total brain fart moment there. Remember, we were generating a random number. Oh, hang on, message equals random. Let's get rid of that. Oh no, I was message string, get rid of that. So writing to there, we're reading there. Let's do a, yeah, we're going to need what we're going to need to do is have a buffer that we build up each time we come through here and read the next character that is coming out of this serial port. So, do we have a buff somewhere up here in the globals? Do we have a buffer? Yeah, so let's say UT 8. What do we call it? Buffer position. Let's just do that for now. Because what we're going to be doing is putting things into a buffer each time around, and we need to be able to increment it to the next position. And then at a certain point, we need to be able to send or report that buffer. Maybe what I should be doing, okay, let's do something different here. I'm going to comment out all of this MQTT stuff and get rid of that. So what this is going to do is just, this should basically behave the same way as that serial reflector thing was before. So we're, well, the message string doesn't matter. And what this should be doing is just looping as fast as it can. There's nothing to do for MQTT. It'll just be reading data coming from the multimeter and reflecting it back to the serial port. I should have done this before. This is just validating that we've got comms to the multimeter, because without that, we're kind of guessing. All right, what's going to happen? So it does its MQTT connection. Come on. Why do I not have comms from the multimeter? Let's go back. What have I missed? What have I missed? Open recent. Serial reflector. Come on. Is Arduino... Oh, there it is. It was just taking ages to open. All right, so let's just check whether I'm opening the port properly here. Oh, hang on. Maybe that. So we need the hardware serial thing because we're opening the extra hardware serial port. Then we have the hardware serial there. So we open port 1, we'll create an object, call it UT61e. Serial.begin, do we have that down here? Oh no, I'm doing serial1.begin. Okay, UT61e.begin. Baud rate, serial, blah, okay. So I'm currently compiling and uploading, but that one's not going to work either. At least I don't think it is, so let's do it again. So we've begun UT61e. Alright, now the functionality that's in this simple serial reflector should be in here, but with you know, all of that other MQTT framework just hanging around. So, bring this back over here a little bit. And let's see if we're at least taking the data from the multimeter and sending it to the... Oh yes, look, cool. Okay, so we're getting the chunks of data coming back from the multimeter again. That's a relief. All right. Now we can actually do something useful. Where? There, in the loop. Okay. So at this point, we are looping through, we're reading data, and we are just echoing it. So what we can do here is, let's start by taking this value and sticking it into the message buffer. So, and we want to stick it in at, what did we call it? G buffer position equals. So that's going to start off as 0 when it's initialized. And no, but we don't want to just do a read because this is going to flush the buffer. So let's just do something here instead. Let's do this character equals UT61e dot read, and then if we echo this character, that should be basically the same thing. But now we've got it in a variable that we can do something with. So we'll say this character, and let's before we increment anything, because we've got to know when to stop. We can't just keep shoving stuff into this buffer. We need to know when to stop. Otherwise, we're going to have a buffer overflow error, and that would be bad. So let's change this to be serial.println g MQTT message buffer. Is this going to work? So what I'm wanting to do here is just each character that comes in, I'm going to stick it in. This is just going to go into the first position in the buffer, and it's going to print it, and then a new line. So what's going to go on here? I have a feeling this is going to cause a, oh, what have I done? Oh, of course, it's not Python. This message buffer is already going to have stuff in it. This could be rather messy. All right, now, while that's compiling, yeah, I'm just, people are telling me the answers. Ah, cool. I really should be paying more attention to the chat because people are actually telling me what the answers are to the problems that I'm facing, like the topic being teller instead of command and instantiating the serial port. Yes. Why not? So Aaron says, why not just take the raw value being provided? Oh, hang on, look at this. Yeah, we're printing the buffer, but the buffer was used originally, like in this sketch, the buffer is used way back up here during startup because it uses that to report stuff, I think. Somewhere here in the connection? Yeah, here it is. So the buffer has already got a bunch of stuff in it. So let's make that a little bit neater. Okay, this is really ugly, but this should make this go away. Buffer position plus 1 equals that. So that should terminate, like the, it should provide a terminator. So now when this prints, it'll just print one character and it won't have all of the trailing stuff here. So what you can see down here is the first column, 105998. That is actually the packet. The first character being reported down here is the packet of data coming from the multimeter. But it's got the rest of the stuff in the buffer left over. So we should be terminating the buffer. Terminating after we put what we want to put into the buffer. All right. Kabletti, my kingdom for a real IDE. Yes, I know. I could be doing this in VS Code or even the new Arduino, what do they call it? Arduino IDE version 2, whatever it is yeah, it does more things. So, oh yeah, so now look, we can see we're not incrementing the position in the buffer, we're just outputting one character at a time, but we are getting chunks of data. Now, I am very tempted to just start shoving these to MQTT. Ooh, hang on, I just got a message from Andy. I've got to check that because this is my back channel slap upside the head. Oh, okay, yeah. He's telling me about that we already solved this parsing problem in the Swag Badge project. Yeah. Trying to do this stuff live is really, really hard. Okay, but we are actually getting data now. So let's just start pushing some of this. Hang on. Where's my... What? I'm just looking at this and thinking we should start publishing even the single characters that we're getting back. So MQTT message buffer, message string, where is null? Okay, so you can see that is happening so fast. These characters are actually being published to MQTT, but it is seeing it as a null value. And look, you can see how fast this is scrolling by. That is crazy fast. Oh, I know why. It's because it's publishing on every single time through the loop. Look at this. It's outside of the read loop. So let's get that. Stick it in there. And so now, instead of all the null values, we should be getting only one MQTT. And that actually shows you how fast MQTT is. Like, this is flickering past faster than, you know, the monitor can refresh. Well, that's probably not true, but it's faster than you can see new lines being printed. And so we are pumping a huge amount of data into MQTT there. As fast as this loop could go, it was publishing. So now we should only be getting a character when it's gone around this. So let's see what we've got happening here. Let's go to the bottom. No, still doing something silly. Message string.length +1. Message string and buffer are different vars. Yes, you're right. Thank you. So, can I do this? That's right. That's left over from all of the dodginess of previously. I don't even know if I can do that. Message buffer.length. We could do... no, that's not going to work because it's not a string. All right. We don't even... What? Why am I even doing that? Why is that even in there? So we've got the message buffer. We're publishing there. And to the raw topic, this doesn't actually even do char array. Yeah, that's just messing everything up. All right, maybe now we'll get somewhere. We're not clobbering the value right before we send it off to MQTT. So, now while this is taking its time compiling and uploading, where are we up to? So we're reading, we're taking the first character, we're taking one character at a time and publishing it. Oh, look, we're getting there. I should leave it down there so that it's not obscured. So you can see these packets, each character of the message packet from the multimeter is being published as a separate character, but we're getting there. So now we just need to start accumulating them and only send it like as a complete message when we have a complete message. We can do this. Well, maybe you can. I'm going to try. So, where are we going to go next? Let's do so what we're dealing with here, these values that are coming in, they're actually ASCII values as they come in over the port. And you can see that there are a couple of blank lines here, and you can see that there are blank lines being reported in here. And that is because the message will be being terminated on the serial connection by like a carriage return or a line feed or both or something, which is the usual way for serial comms. So what we could be doing is looping, we could be incrementing the position in the buffer each time we get a new character come in. So let's do this. G buffer position plus plus, and just for now I'm going to do that. So this should be technically, functionally exactly the same as before. But no, it's not, because next time around buffer position will have been incremented in the global variable, so it will then add on to it. And we will end up with a buffer that just grows. So for every character we get, it's going to grow. Now, let's see if we want to look for a delimiter. So let's see, we've got the byte that's come in here. We could do a comparison on this. All right, I'm going to wrap all of this. Let's see, we'll do if this character equals 10. And that is because I happen to know, having messed around with, I'm just going to pull this up, ASCII table. 10 and 13 are the characters we care about. ASCII table. I have bashed my head against this problem many times. ASCII table. That's a little bit hard to read. All right. So null is 0. Yeah, so earlier, I didn't really explain myself earlier, but back here, where I was saying I was putting a 0 into the message buffer, that's because I was putting a null character in which terminates the string. So if you look at this table, position value 10 is a new line, and position 13 is a carriage return. So what I'm doing here with looking for a value of 10 as the character, like the ASCII value for it, that is looking for the end of the line. And the usual way to do this is you terminate with a carriage return and a line feed. Now some systems use different things, but I'm pretty sure when we were looking in the datasheet, it did say that it was terminated like this. So, hang on, I better go back into the chat. Size of. Fast enough, hunt? Yeah, as a single character message. Count equals 0 if count is less than 6, add to array. Yeah. All right. Some call it fun said, for your sanity, perhaps refactor the get UT61 char to own function. Yes. Sorry, I only read that. And also, Aaron said count is 0 if count is less than 6, add to array. Yeah, so what I could be doing is just counting characters, because we know we've got, is it 14? In the, that would actually be like a simpler way of doing it. If I just counted to 14, we know that it is 14 characters long in the message, I could count to that and then just output it. But I prefer to look for the end character. So let's just see what happens here. All right, so we're looking for if the character is equal to 10. No, we want it if it's not equal to 10. And then we want to do something else if it is equal to 10. So if the character, all right, if the character is not equal to 10, we want to do this stuff. Up to, let's leave it printing. In fact, we want to do, oh, come on, me type good. So what this is going to do is if the character is not 10, so it's not the carriage return or line feed, whichever one, it will increment, and we don't want that in there anymore. Let's get rid of that and move it down here. It's starting to kind of make some sense. Let's get rid of this line as well, because I don't think we need that anymore. All right, let's look at the logic of this. What am I doing? So we're reading from it. If it is not a carriage return, or is that line feed? I can never remember which way around it is. Anyway, if it's not the end character, we want to take the character, stick it into the buffer, and then increment the buffer position. If it, oh, hang on, we want to do, and then print it. So what this is going to do is as the buffer builds up, it's going to print it progressively. So this is one of those things where if it fails to catch the terminator, it's going to just grow forever. So this will be interesting to see. And then if it is the character 10, it is going to, we want to null terminate at the position +1, and then it's going to publish it. Now, is this hacky code even going to compile? I don't know. Let's see what happens. Compiling. Okay, everybody drink. This should be a drinking game. Maybe the drinking game should be every time I compile and every compiler error. Uploading. Hey. I didn't get a compiler error. Now let's see if it burst into flames on my bench. And if this, ooh, look at this. Oh, hang on. I don't think I'm printing. Oh, there is definitely something weird going on here. Oh, I know. I'm not resetting the buffer position. G buffer position equals 0. Go. Buffer overflow error. Come on. Compile. Okay, I think I need to take a drink for that one. So maybe it's not the terminator. I think what it's doing is growing. Oh, hang on. That actually looks okay. What? This is working. We're getting values coming up here, and we're getting the same. Hang on, we've got a B there, and there's no B here. I don't know what the B is. How many digits is this? 1, 2, 3, 4, 5, 6. I've got to count again. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think that B is... maybe that's the other delimiter. Because I think it's 14 bytes, including character turn and line feed. Yeah, Cabletti says, I think it has a character turn at the end or beginning. Yeah. So, this is not pretty, but hang on, it's 11:53. We've done it. We actually have data from the multimeter publishing to MQTT. Now, it's not very usable right now because it's just the raw packet of data coming from the multimeter, but we do have something. Now, hopefully you can all read this okay. I'm going to zoom this terminal way in. All right, so this is the raw packet of data. I currently have my bench supply set to 6 volts. The multimeter is reading 5.99 volts. And we are getting on MQTT 105998 semicolon 000:0. Hey folks, we're actually getting there. This is really cool. All right, I'm going to change the setting on the power supply to VSET 3.3, go. And look at that, the value coming back up in MQTT has changed, 103297. And the multimeter is reading 3.297. Well, what do you know? This is kind of astounding. All right. I feel like I need to stop and take a breath now because we've kind of got somewhere that it's vaguely useful even. Like if we had some kind of a UT61e protocol decoder that was subscribed to MQTT, we could be using this data and pulling it out. Chris says, we get signal. We get signal. hang on. Okay, I know this is a, I think I know where that's from. That is from a demo scene video. All your base are belong to us. Yes, all your base. We've got to do this. Where is... I've just got to find it. Hang on. YouTube. I wonder if I'm even allowed to do this. Can I play a YouTube video on a on a live stream? All your base. Let's see if this works. I'm not going to play the whole thing.
Someone set up Octobot.
Anyway, this is a classic demo scene video from a long time ago. That's a very old one. So, Chris, did I get the cultural reference correct? Yes, someone set us up the bomb. Now, back to here. Hang on. Why is that saying Bell? What? I was doing a double take on this. It says Belle for the topic. This part of it is the topic name because I did the subscribe in verbose mode, and instead of saying Tele, it says Belle, and I think that that cable tie is correct. That B that you see here coming through, like wrapped around onto the next thing, that is because the message that it is publishing actually has the terminator, and so it's wrapping in the terminal that I'm displaying it in here. So that terminating B is bad. Okay, so we don't need that serial reflector anymore. So let's try yeah, so we need to be looking for both 10 and 13, because I think it's terminating it with both. Now, I'm just going to reverse the logic of this. So I'm going to see how I'm looking for it. If this character is not 10, then we take the character and we process it. This kind of made sense from a logical flow point of view. I'm just going to switch this around. But if we're going to check for both values, let's just reverse that logic. In fact, what I should be doing, just to annoy some people, I'm going to do this. Just to be compliant with the bar group programming standards, always put the constant on the left. Now, so what it's doing is, if the character is 10, we are going to terminate the buffer, reset the buffer position to 0 and publish. Otherwise, we're going to handle the character and output it. Let's get rid of. I'm just looking at this code now. Now that I've rearranged it, this is not behaving the way I expect, because this message buffer, hang on, I just realized something. What's coming up here in the serial console is actually not correct. Look at this, because what's happening is, if we handle, so it's not delimited, then we are simply writing the next position in the buffer and echoing the entire buffer, but we haven't terminated it, which means that we are going to get an echo for every new character that's added. And so what we're seeing here on the left is actually a whole lot of lines that are repeating, because what I'm wondering is, why aren't we seeing this grow like a triangle? It should be adding one character each time. And so I bet if we terminate this after this, am I doing this right? So I'm terminating it after the current character. What we should see is the buffer growing as the message is built up, because what we're doing is we're printing it every time we go through the loop. We're only publishing when we get the delimiter, but we're printing on every iteration through. So this is actually lying to us. This could be giving incorrect values coming up in here. Now where did my, oh, I'll just move my thing here. So the value, these messages that are being published to MQTT, these are only being published, yeah, that's better, look at that, so pretty. So these values that are being published to MQTT, I've got to drag this so that it's readable. It is only being published when we hit the end character. But this print here of the buffer is happening every single time around the loop if it isn't the end character. So yeah, so what we were seeing before was actually a buffer that was already populated, and then it was just, you know, writing across it, overwriting the previous buffer. Interesting. Okay, so what we could do is, in fact, if I took that out of there and echoed it there, that would also solve the problem. And then we don't need to be doing this termination. And so what it does is it adds the character and increments it, and it only publishes or writes to the serial when it's got the delimiter. All right, that makes a bit more sense now. Where are we at? Oh, we're at 12. We're actually at 2 hours. I feel like messing around with this a little bit more. But we're kind of at the point now where we are taking data and publishing it in a way that we could use. Remove +1 in. Yeah, Cable Tie says, patience peeps, John will figure it out eventually. Because you reset buffer to 0, but you've moved it now. I tell you what, live coding is hard. If you were watching me coding normally, I'm talking constantly while I'm trying to do this. My brain is not set up for this. So, all right. Now I've got to try reading the comments. Aaron said, or not, and I just threw up. All right, yes, that's cleaner. At 2 hours, we only started 46 minutes in. Check if there actually is a bell topic with the right value in it. All right. Okay. Breathe. Where are we at? Now, most of what we've done today, you know, it's one of those things like last week we soldered 2 wires on. That's the summary of what we achieved, as someone facetiously said, but it was kind of accurate. This week, when it all comes down to it, I mean, the rest of this boilerplate code, we haven't touched this. This was copied from another project, and all this does is MQTT connections. There's a callback that's not used. There's Wi-Fi connection. There's, you know, that isn't even used at the moment. I just left that in there for reference. Setting up all these topics. This is all boilerplate stuff. When it all comes down to it, apart from a couple of little things like making the hardware serial connection and setting up the serial object, all we've done today, with all of this messing around, is this little chunk of code here. That is not really very much. But, Aaron said, sorry, that was me as a joke. Yeah, I know it was a joke. I thought it was funny. I was not offended, don't worry. But, yeah, but my point is that if you just stop and look at the output, what has actually been created today is this chunk of highlighted code, and even a fair bit of this is, you know, not as nice as it could be. But yeah, so if you were watching me doing coding normally, I normally sit in total silence, obviously. I don't have an audience. And I will be sitting and thinking about things, doing absolutely nothing for a while, trying to get my brain around what it is I'm working on. And so trying to explain what I'm doing and the reasoning behind it as I'm doing it is kind of hard. So for people that do live coding, like do coding on live streams regularly, I don't know how they can do it. It's tough. So, where are we? I've got to reset my brain again. Where are we at? All right, so we are reading characters and we are publishing. Now, I'm not really quite satisfied with what we're doing with these delimiters because we've got this B issue and this weird thing coming in the MQTT reporting with this B character coming up here and the trailing B on here. So we need to be doing some checks for both carriage return and new line. So at the moment we're checking for 10. We should be checking for 10 and 13. But my head is spinning here a little bit about how to actually do this. The obvious thing to do is just to do this. Oh, I type good. So that it will catch either, in fact, let's just do this. What this is going to do though, I don't think this is going to behave the way that it might seem obvious at first glance, because it's going to process this twice for each packet coming from the multimeter. So we're probably going to get like a blank entry or an entry with the previous buffer still in it. I'm not sure. But we need to be a little bit smarter about it than this. Scott says, remove the plus in line 118. Okay, so that might well be my problem. Yes, you're right. I am terminating that. Oh, yeah, look at this. So we're getting a 1 coming through. But anyway, yes, you're right. So we've got, I think you're right. Let me just think through this. So down here, we are incrementing the buffer and coming back up here. So if it is, yeah, at this point the buffer position is already incremented. So we should put it directly in there. You are correct. Yep. I had an off by 1 error there. Yeah, some call it fun. Scott, I tried to tell him. Yes. Yeah, and Cable Tie says you'll get a publish, then an empty publish. Yep. So, so we need to put another condition inside here, and there's probably a neater way to solve this, but I've got an idea. Yeah, Cable Tie, you are spot on. You are smarter than me. So we get a publish, then an empty publish. And thank you to all the people that were shouting at me to remove the +1 from the buffer position here. All right, so now what we're getting is we are publishing when we hit the first line ending character, and then we get another line ending character, but by that point we've already reset the buffer, so the buffer position is 0, so next time around we have an empty buffer, and then we publish again. So I think that now, all right, I can think of a really crude way to do this. People are probably not going to like this, and I'm going to have a few people shouting at me, but let's just see if this works technically. So what we're doing is checking if we have either a carriage return or a new line. And then we are only doing the rest of this stuff if it is this. So essentially what we're doing is consuming the 13 character and doing nothing with it, just throwing it away. So now we should get rid of that empty publish. Like, we're still getting B in here. It's still something odd going on with it. But now we should only be publishing. Actually, this is going to be an interesting indication. So what I think is going to happen is that we'll lose all the blank lines, and hopefully this B is going to go away. No, it hasn't. That is interesting. Have I just literally... No. I haven't mistyped that. Okay. All right, so that's got rid of the blank lines. We are only publishing if we hit this, and we are delimiting on either of them. And so essentially this character is just being totally ignored. Nothing is happening with it, and we are incrementing if it's anything other than either of these two characters. Well, I think we're getting closer to something that is useful, amazingly. There's a little bit more, there's some cleaning up we need to do, I think, because, let me see what, if empty, ignore. Yeah. So Separate the test for 13 and just discard it. Yep. Just do if not null. Yep. Yeah, so instead of doing this comparison here, we could do, yeah, we could do an if not null on the message buffer. It's another way of doing the same thing. Ooh, Michael said the B is back. It did run as T for a little bit. Yeah. I didn't actually see it come out correctly. Did I do something that would have screwed that up? Now, I am actually going to stop soon because I kind of feel like we've got to a reasonable place. My goal was to have something pushing to MQTT by the end of the live stream, and at least we've got the raw packet. We're not parsing it in any way yet, but we've got data coming from the multimeter, and we are reading it. We are connecting to Wi-Fi and pushing it to the broker, and I count that as a win. I think that is that's a nice step forward for this little project. So parsing it is going to be an issue. So yes, I need to figure out, what is the next thing? I need to figure out what is going on with this B. So it's this delimiter that is being strange. So, what should we do? I wonder, G buffer position is it? I think I see it. Ooh. Or do I? No. For a moment I thought I saw the problem. So what we're doing is at the new buffer position, we are writing 0 to terminate the string. We are resetting the buffer position to 0 and then publishing. Just thinking this whole thing through a little bit, which is very hard to do on a live stream. So, I don't know. My brain is fried. I think I'm going to have to stop and think about all of this. It was tele for one upload. Yeah. Guessing the B is in the other code for MQTT since print is clean. Didn't get accidentally changed. Yeah, cable tie said check the obvious. A tele topic string didn't get accidentally changed by any chance. No. What? Hang on. Tele is back. How did this... Craig says, I know software companies who would have been trying to sell this 30 minutes ago. Yes. All right. Rule 1. Okay. But look at this. We are getting... Our publication is getting doubled up now. So I haven't hit... Have I hit upload recently? I don't think I have. How has that changed? It didn't change after an upload. It changed at some point. And why are we getting this one value being published on here? There is still some weirdness going on in here. Did I revert? No. Well, I don't think I've... Your MQTT window isn't scrolled to the bottom. Yeah, it is. Oh, hang on. You're right. It was not scrolled to the bottom. I've been chasing a ghost. Thank you. Thank you, Brian. So, that's embarrassing. All right, that means I think we've actually fixed the problem. So when it was, as it is showing up correctly now in the serial console, and what is showing up in MQTT is matching the serial console. So that +1 buffer thing, I suspect when I changed that, that was the last upload I did. I think that fixed it. So thank you very much for that suggestion. All right. That's really disconcerting because, look, I'm going to go into this. Right now, I am scrolled to the bottom of this terminal. I'm going to drag the terminal back up a bit, and I'm not touching anything. Is it changing? No. I thought maybe it would continue scrolling at the offset position, but no, it didn't. Weird. I don't understand. Okay. All right, and what that means is we're actually in a better shape than I thought, because I thought we still had a problem with that terminator, and we don't. We are now correctly publishing. If we do a side-by-side comparison, I mean the font size is a bit different. I'm going to zoom out so that it's approximately the same. That looks approximately the same. So the value being published to MQTT, and you can see they're staying pretty much in lockstep. The value being reported on the serial console here is the value being reported here. In fact, what I'm going to do is Control C that. I'm going to get rid of the verbose flag so it doesn't print the topic. It's just going to print the values. And those values are tracking each other. So we're getting the data reported in the serial console, and we're getting it reported to MQTT. I'm pretty pleased with that. I think we can... yeah, I think that is a good checkpoint. Someone earlier said that's a good checkpoint. I think this is a good checkpoint. We now have raw data from the multimeter. We're detecting the end of the packet, we're reporting it to the serial console, and we're publishing it to MQTT. So I think that's a win. Change the setting on the PSU and watch it, Scott said. Okay, let's do that. Now, one of the things to think about, of course, is once we parse this, hang on, I'm just going to switch over here. What am I going to do? What do we set it to? VSet, let's go for 2.2 volts. 2.2, badoom. And there we go. It's changed on the display. And I'm just trying to keep it aligned. Is it matching the position, or is... Yes, it is. 17, yeah. It is matching. Nice. Now let's go VSet 25.32. I don't know how accurate that's going to be. Oh, no, it didn't let me go that high. VSet 13.12. Enter. Hang on. Oh, I turned off the output. What did I do that for? Okay. So I've got it set to... The power supply is set to 13.12 volts. The meter is reading 13.114, and we are getting 113.114 coming up in the console. Nice. Nice. So Aaron said, save current value in variable and check new value is different to variable. If it is, then publish, else don't. Yeah, that could be interesting. So, yeah, okay, so this gets into what I was thinking about. I'm just going to go back to overhead for a second. 13.114. So that you can see there, 13.113, you know, that is what we're getting there, 13.113, 13.114. We're not splitting out the value and putting the decimal point in the right place yet. We can get to that. But I think we can feel pretty good about this live stream. At least. Cable Tie says that'll be for version 2. Oh, Scott said MQTT is one reading ahead of serial. I was wondering if my eyes were deceiving me on that. You know, I've got to get a ruler and hold it on the thing. Where is a... It's moving too quickly for me to be able to check the correlation. But I have a feeling you're right. They're not perfectly in sync. Wonder which one is ahead of which. Don't know. Anyway, it's I think it's within time that I'm not too worried about it. Publish a line count. That's an interesting idea. Yeah, Peter said screenshot. Yeah, that would do it. All right. Given that it's now heading towards 2.5 hours, I'm going to stop. But before I stop, I just wanted to mention where to from here for this project. Okay, so to-dos. We need to be able to parse this packet and pull the data out of it and put the decimal in the right place and figure out the mode, like whether... I've just been doing all of this in volts range. Actually, let's... I am going to put it into a different range. So instead of measuring volts, what will we measure? Going to get this off, turn off that. Let's try measuring a resistor. So ohms range, I'm just gonna, I don't even know if it's gonna make good contact. It's just sitting there. Well, the value's jumping around. Maybe that's a good test. Come on, make contact. I don't even know what value this resistor is. I'll hold it on there. 3.3K, okay. Come on. Oh well, it's jumping around, but that doesn't actually matter. Okay, I'm gonna do this. Clip on some test leads. Clip it on here so we can get a value coming out of it, because I want to see. I mean, you can probably see it now. Oh no, you can't because I'm on the overhead camera. So 3.276 kilo ohms is what it's reading, and if we go back to here, it is saying 203.276. So we're getting an ohms range. Oh, and look, the characters on the other side have changed. So somewhere over here, one of these characters tells us what range the meter is, or mode the meter is in. So we need to be able to parse that and figure it out. All right, so future work. Take this packet, pull out its relevant parts. So parse the packet. We need to get the current value, like as a float or something. We need to get the mode. I think there is a range value because you can have, you can be in volts mode, for example, but then there are different ranges and the multimeter will switch between ranges automatically. So I think we need to pull that out. Anyway, we'll need to look at the spec and see what it is sending us and then be able to extract all of that from this packet. Then we need to decide how we're going to report this. I think reporting the raw packet is possibly useful, maybe not eventually, but then do we have like a volts topic and an amps topic and whatever? Do we stick it all in JSON and then publish that? If we do, what format does it have? And then the other part of this, of course, is shoving all of this stuff into MQTT is okay. Oh, the other thing is that I would like to publish values. Oh, I'm just thinking ahead to this. Because what are we going to do with this data? My whole goal with this was to be able to have an on-screen multimeter so that when we're doing like live hacking sessions, you can see the values that are coming up when I'm measuring stuff and you can see them on the screen. But it would also be interesting to take these values and pull them into InfluxDB, for example, and then have Grafana So what we could do is turn it into a logging multimeter where all of the values that it reads go into the influx database, and then we can chart it using Grafana. That could be kind of fun. And yeah, as Brian said, UT61e to MQTT to InfluxDB to Grafana equals oscilloscope. Yes, it's a 2 Hertz sample rate oscilloscope. Absolutely. That could be quite interesting. So I need to think about how I would take this data and display it on screen in OBS. So I might need some little program that runs on my computer and opens a window and just displays digits and acts as an MQTT client. So some kind of like a GUI MQTT client. I don't know. Let's see what we can figure out. Yeah. Oh, Scott has suggested a JSON format, so volt 0, amp 0, ohms. Yeah, that makes sense. So we'll take all of the possible readings and we'll make a JSON structure that includes them all, and then just populate the value into whichever one it is based on the mode that we're in. Yeah. Oh, Peter says bye. That's the yeah, the Simone sign off, isn't it? Yeah, well, Aaron said the other thing is value unit and like range or something. Yeah, so that's a different way of doing it. Anyway, we can talk about this. Let's talk about it on Discord perhaps. Peter is pretty certain that it is lunchtime, and I am pretty certain that Peter is right. So, let's stop. Thank you for coming to my live stream. Thank you for coming to my TED Talk. I'm going to run off now and eat some lunch because I'm hungry. And I need to decompress my brain now after coding live, which is really stressful. So I probably should read back some more of the Scott says, got to find a pizza place that delivers on Sundays for John. Yeah, there are a couple of really good pizza places close to here. And I will see you all really soon. I don't know why I haven't gone yet. It's like one of those you hang up, no you hang up moments. I feel like I've got more that I need to tell you, but I can't think of what it is. So I'm just going to stop. All right, I've got to pack all this up. Have a great weekend, and I will talk to you all really soon. Thanks. Bye.